there, third graders! This week in math, we're going to continue talking about fractions, and in doing so, we're going to be comparing them. So we're going to take everything we've learned over the last few weeks about what fractions are, how we build them out of shapes, how we represent them on the number line, and all of that, how we decompose them, and we're going to use that to help us compare fractions. For this video, what you need is a sheet of paper, a pencil, and two colors. Those could be two different markers or two different crayons, or you could even use two different highlighters, two different colored pencils. But pause the video now and go get those materials: pencil, paper, and two colors. Okay, so we're going to be comparing fractions. We've compared numbers before. This isn't new to us. We've compared using these symbols, which mean greater than, less than, and equal to. We've done this. We've compared numbers like, let's say, very simple, when we were significantly younger than we are now, like 10 is greater than 4. We did that a long time ago. 10's more than 4, therefore it is greater than 4. I could write that the other way. I could write 4 is less than 10. Both of those statements are true. We also did it earlier this year with larger numbers. So if you were in my class, we did, ooh, that was interesting. Well, apparently I'm not going to get to zoom the way I thought I was. We did much larger numbers. For example, we may have, in my class, and I bet you guys did in the other classes as well, maybe comparing a number like 1,265 is less than 3,293, because 1,000 is less than 3,000. So we've compared numbers before. Now what we're going to do is we're going to extend that learning to include our new understanding of fractions. Now here's the cool thing about comparing fractions. There are tons of different ways to do it, and I'm going to show you just a few today. And all of the different strategies that I introduced today in this video, there will be review videos available for you through Khan Academy and a couple other different resources that you can go back and use to help you remember and practice these different strategies. You'll learn even more comparing strategies when you go on to 4th grade and 5th grade and so on and so on. So let's jump into it. The first way, and the most basic way, to compare fractions is to utilize visual models. So we've drawn pictures lots before with fractions. So what I want you to do right now is I want you to quickly pause and draw these two rectangles. You'll notice the rectangles are identical in mine. I want you to do the very best that you can to make two identical rectangles, because it's important that when we compare fractions, we're comparing fractions of the same whole. So it's important that both of my wholes, or both of my rectangles, are exactly the same. So pause now, sketch these rectangles, and then turn it back on when you're ready. Okay, so I want to represent 3/8 in this first rectangle. So I know that I'm going to partition my rectangle into 8 equal parts, because that's what my denominator is. So I'm going to do my very best to draw some straight lines. So I'm going to do it this way, I think. That's pretty close. I'll stick with it. And I'm going to take one of my colors, and I'm going to shade in 3. So 1, 2, 3. So that represents 3/8 now. I'm also going to represent 6/8 in my other rectangle. So again, my denominator is 8, so I'm going to partition into 8 equal parts. Again, trying to make it identical to rectangle number 1 so that it is comparable. Pretty close. I'm going to take a different color, and I'm going to shade in 6 parts, because that's what my numerator is. 1, 2, 3, 4, 5, 6. So now, if we were to imagine that these were brownies. I always bring it back to food, don't I? Let's imagine these are tins of brownies. Like I made a sheet cake size, a rectangle size pan of brownies, right? And actually I made 2. And I ate 3/8 here. And then when I made the second batch of brownies, I ate 6/8. In which case did I eat more brownies? I definitely ate more over here. Would you agree with that? Significantly more, actually. I ate 1, 2, 3 more brownies on that side, or 3/8 more brownies. So I can compare these by saying that 3/8 is less than 6/8. The visual model allows me to visualize these fractions. So I had to cut both of my rectangles the same way, and I had to shade them so that I could see that 3/8 is less than 6/8. So that's one method, is to draw it out. The hardest part, of course, is you have to make sure that when you draw it, your representations are the same size. Okay, so I'm going to move on to another strategy. But in doing so, I'm also going to stick with the visual model to help us understand the other strategy. So we can, actually, let me jump ahead from number line. We'll go back. So we can also compare fractions if they have the same denominator super easily. We saw on that last slide that when they had the same denominator, it was easy to partition them the same way, shade them based on the numerator, and then compare. I also noticed that if I took my denominators away, then, and just compared my numerators here, 3 is also less than 6. So when I'm comparing fractions and I have the same denominator, the numerators really are the ones who tell the story. Let's look at that visually and then practice it. So let's say I've got 2 pizzas and they are cut into 6ths. I'm not quite sure why I chose that denominator because it's not an easy one to draw, but I'm going to do my best. So you can go ahead and pause right now, draw those 2 circles, and then we're going to partition them into 6ths. So pause and do that now. Okay, so I've partitioned into 6 because that's my denominator. I'm going to take one color and I'm going to shade in 5. So 1, 2, 3, 4, 5. That represents 5/6. I'm going to take a different color and I'm going to shade in just 2. And I think it's pretty clear from my visual model that 5/6 here is greater than 2/6 here. And that's because 5 is greater than 2. So when the denominators are the same, we can just compare the numerators. So when the denominators are the same, we can just compare the numerators. I want you to pause now and copy that down before I move on to the next slide. So you're pausing and copying that down. So let's practice it again. Now, I know that if the denominators are the same, I can compare the numerators. 2 is less than 7. Now I'm going to prove it. I'm going to draw this into 8ths. You should be drawing it as well. If you ever need to pause, and I don't tell you to pause, you don't have to wait for me to say it. You can pause at any time. You can rewind at any time. All right, so they're broken into 8ths. I'm going to shade in 2 in one color. I'm going to shade in 7 in another color. And it's really clear to me that these 2 take up much less space than these 7 over here. So that's true. 2 is less than 7, or 2/8 is less than 7. Again, I didn't need my visual model because I knew that the numerator, if the denominators are the same, the numerators tell me the answer. 2 is less than 7, so 2/8 is less than 7. But up here, what I did was I used my visual models to justify my math or to explain my reasoning. Is it me, or does this just kind of look like a face? He's just happy because of fractions, because fractions are awesome. All right, let's do one more of these. Pause and draw the circles. I'm going to break it into fourths. I am going to shade 1/4 on this side. And I'm going to shade 3/4 on this side. And I know that 1/4 is less than 3/4. I also know that 1 is less than 3. So it's easy for me to do that even without my pictures. How cool is that? The math is kind of already done for you. So let's do a quick couple practice problems without our visual models. So if I've got 2/5 and 3/5, the denominators are the same, and 2 is less than 3. So 2/5 is less than 3/5. Let's look at the next one. 3/8 and 1/8. Both of them are eighths. 3 is greater than 1. So 3/8 is greater than 1/8. 6/10 and 5/10. Both tenths, so I just look upstairs at that numerator. 6 is greater than 5. Pause now, do that last one on your own, and then unpause to check your answer. I know that 2 is less than 8, so 2/9 is less than 8/9. All right, let's move on. So far we've used visual models, and we've looked when we have the same denominator. Sometimes we don't have the same denominator. Sometimes we have the same numerator. And this one can get tricky from time to time. So we're going to rely on what we know already about visual models to help us. So I'm going to start by drawing or representing 4/8 in my first rectangle. So you need to pause and draw 2 rectangles. I'm going to partition that first one into eighths, just like we did that first time. And I'm going to try my very best. I'm going to do it this way. Double check. That was a really bad one. There we go. Double check. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And I'm going to shade in 4 of them. 1, 2, 3, 4. Now, in this next one, I'm still shading 4, but I'm breaking into fifths. Fifths is a little bit harder, so let's see. Not too bad. Okay. The first thing I notice is that over here I broke it into eighths. And, whoopsie, wrong tool. This one here, an eighth, is significantly smaller than a fifth. A fifth is a way bigger piece. If this was cake, I would want the fifth because it's a big, chunkier piece. The eighth is skinnier. Okay, so I need to shade in 4 of my fifths. So 1, 2, 3, 4. Whoa. So the picture is showing me that 4/5 is a whole lot more than 4/8. Interesting. So it actually looks like this. 4/8 is less than 4/5. Now here's where kids get tricked all the time. I'm going to give you the secret. Kids always say, oh, 8's greater than 5, so it goes this way. But you can see from this picture right here, that's not true. That is not true. Get rid of that. When we have the same numerator, we look at the denominators. But the bigger the denominator, the smaller the slice. Do you see that here? A fifth is a lot bigger than an eighth. So the bigger the denominator, the smaller the slice. So what you end up with is kind of a backwards comparison, right? When we had the same denominator, the numerators told us the story and it was easy to compare, right? If the numerator was greater, then the whole fraction was greater. That's the opposite here. When the denominator is greater, it's a smaller fraction. Go ahead and jot that down now. Okay, so let's practice this again. This time I've got fourths. and I've got sixths. Okay, so in both cases I have a numerator of 2. So 1, 2, 1, 2. Again, immediately looking at it, I can see that these pieces are bigger than those pieces over here. Much bigger. So if this was cake or pizza or money, I would want this side because it's more. The pieces are larger. So 2/4 is greater than 2/6. Okay, so one more. Make sure you jot those notes down. 1/8, 1/4. So looking at it right now, I know these pieces will be larger. If I cut that cake into fourths, and I cut this cake into eighths, I'm gonna go if I've got one of these versus one of these, it's really easy to see that this is significantly larger. So again, I looked at the denominators, and the piece that had the smaller denominator was actually the larger fraction. Let's do some practice. Okay, if I have 2/3 or 2/9, thirds are larger than ninths. 4/6 or 4/4. Well, that one's actually even easier because 4/4 is a whole and 4/6 is less than a whole. But I also know sixths are smaller pieces because I have to take more cuts to make sixths than I do to make fourths. 1/10 or 1/2. Well, halves are larger than tenths. 2/8 or 2/3. You do that one and then come back and check your answer. I know thirds are larger than eighths, so I would rather have 2/3 than have 2/8. 2/8 are going to be really small, skinny pieces. Okay, so now let's go back to that number line that I skipped over before. Okay, this is super basic. Okay, this is kind of a throwback to last week with the number line. So if I want to plot 2/6 and 4/6 on my number line, I'm going to say that this is 0, this is 1, and I'm going to break this into sixths. So let me cut it in half, and then thirds on each side. Okay, here's what I'm going to do. This is what makes the most sense to me. I'm going to plot one of them on the top, and I'm going to plot the other one on the bottom. Okay, so this will be 1/6, whoopsie, wrong color. 1/6, 2/6. Okay, and this is going to be 1/6, 2/6, 3/6, 4/6. Okay, I can see 4/6 is greater than 2/6, or 2/6 is less than 4/6 because the 2/6 is closer to 0 on the number line. So anything closer to 0 would always be less on the positive end of the number line. Let's do the same thing down here. I'm going to partition my number line into thirds. Let's see about there. Sure. Okay, so I'll call this 0, 1. All right, I'm going to do 3/3 on the top, so 1/3, 2/3, 3/3. Okay, and 1/3. Well, that one's pretty obvious to me. 3/3 is greater than 1/3. So I can show my comparison on the number line kind of just like another version of a visual model. Okay. All right, let's get to some more practice together, and then I'm going to send you off on your merry way to do some math. Okay, 4/8, 5/8. All right, so first thing I do is I look at it and I say the denominators are the same. So if the denominators are the same, I'm going to think back to earlier in the lesson. If denominators are the same, I just look at the numerators. 4 is less than 5. Now I'm going to prove it because That's what mathematicians do. So break this into eighths. Woo, that's kind of a swervy line. Break this one into eighths. Bad line. Oh my. That's better. I'm going to shade this one for 1, 2, 3, 4. And I'm going to shade this other one 5. 1, 2, 3, 4, 5. And yeah, that justifies to me that 4/8 is less than 5/8 because less of my circle is shaded in 4/8. Okay, let's do it again. 3/4 and 1/4. Okay, both of them are fourths. I already know the answer. Looks like that because 3 is greater than 1. But I'm checking my work. So let's do it this way. I'm going to break those into fourths, 4 equal parts. And I'm going to shade 3 over here. And I'm going to shade just 1 over here. And yeah, my picture proves it, huh? That 3 is more shaded than 1. So 3/4 is greater than 1/4. All right, next one. 2/3, 2/4. Now this time, I have the same denominator. So my instinct, the first thing I want to do is say, oh, 4 is greater than 3. But I know that's not true because if I break this one into thirds, and I shade 2 of them, 1, 2, and I shade this, break this one into fourths, and I shade that 1, 2. Look at that. Do you see how this one is this much bigger? This is a great comparison to show me that a third is larger than a fourth. So 2/3 is more than 2/4, even though 4 is greater than 3. Okay. Again, I've got the same numerator, different denominators. Oh, why do I keep giving myself sixths? Those ones are not easy to draw. Okay. Maybe they're not easy to draw for me. Maybe they're easy to draw for you. I guess I shouldn't assume that they're hard for everybody. They're just hard for me. Okay. Oh, that one didn't need to be. Okay. I was so focused on how hard it was, I was messing up. Okay. Here's a good example. If I was just looking at 1/6 versus 1/4, do you see how this piece of pizza is skinnier than this piece of pizza over here? This is a big honkin' piece of pizza. And this is a probably normal sized piece of pizza. So if I have 3 of those versus 3 of these, I can also see that this is like basically half, right? This is 1/2 of the pizza, and this is more than half of the pizza. So I would rather have 3/4 of my pizza than 3/6 of my pizza, because the sixths are smaller pieces. Okay, I think this one is our last one. Whew. All right, I made this one a tricky one as a challenge. If your mind is totally blown right now and you want to go back and look at something else earlier in this video, I recommend you do that. If you feel like this wasn't that hard, then check out this challenge problem. Okay, so I'm going to call this 0, and I'm going to call that 1. Now, if you see, I have different numerators, different denominators. So this one's a challenge. Okay, so I'm going to start by breaking my top of my number line. So I'm going to go like this, and I'm going to break it into tenths. So So 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. Okay, and I'm going to plot that right here. This is 5/10. Okay, now I'm going to do the bottom of my number line with the other one. And it's halves, so I'm just going to cut it in half. I am going to plot that as 1/2. label it, and from there I can see, hey, they're equal. Okay, so we did a whole bunch. We looked at visual models, 2 different ones, where we were drawing it or where we were looking at it on a number line. We compared fractions that had the same denominator, which was super easy, right? Because you just look at the numerator and it tells you. We compared ones that have the same numerator, which can be a little bit more confusing, but not anything that you guys can't handle. When the numerators are the same, you look at those denominators and you say, bigger number, smaller slice. And then you kind of compare backwards, right? So if it's 2/4 and 2/8, I would rather have 2 pieces from a cake that's only cut into 4 than 2 pieces from a cake that's cut into 8. Because that's 2 small pieces, and that's 2 large pieces. These will be large, and these will be small. So that's actually greater. And then we did some practice on the number line as well. So you guys are set for the week. If you need help, please reach out to me. There's going to be some small groups available, and I'll talk to Miss Court and Miss Wishart and see if they're going to do them, or if they want me to invite you to mine. But I believe in you guys. You can do this. Go forth and be mathematicians.